here is one of the ways that we're going to take notes today. Okay? We're going to make ourselves a graphic organizer. And I got you all this fun colored paper. I could totally give it to you in just regular line notes, but that is so boring. Okay? So we're not going to do that today. We're going to do this. So you see how my paper is like landscape? Like if we're talking computer language, it's landscape. First thing I want you to do is fold the top over about 1.5 inches or 2 inches. Okay. Now we're going to work smart. While it's still folded over a little bit like this, I'm going to take my pencil and I'm going to run my pencil along the edge of the fold so that when I unfold it, there's a beautiful straight line right there. Got it? You ready to go on? One should take the right-hand side of the paper and fold it. We're not folding it in half, though. We're folding it like that-ish. So that if I unfolded it, I've got a big section and a little section. You understand? Yeah, thirds would work. You don't have to measure, though. Maybe a little bit bigger. Yep, that's good. That's fine. Got it? Now we're gonna draw another line. However, when I start my line this time, I want to start it at the previous line. So it looks like that. That's fine. All right, you ready to go on? You got all your folds made and everything? Yes? Okay, here we go. Today we're talking about the classification of numbers. We got to talk about the different sets of numbers there are. I think you've probably maybe thought about this in your head. Maybe you've talked about it in other math classes, but we really have to talk about it today because I need to be able to no, not today. I need to be able to use the correct vocabulary with you. The problems in your homework are going to use exact vocabulary, and you need to know what that means. Okay? So we're going to use this graphic organizer to arrange our thoughts about sets of numbers. Okay? Excuse me. Is that dark enough? Okay. All the numbers that we're talking about today are real numbers. Now, this is always when somebody goes, oh, if there's real numbers, are there fake numbers? And I don't laugh because I don't think it's funny. But then I say, well, there's not fake numbers, but there's imaginary numbers. And then they're like, ha, ha, ha. And I'm like, I'm not kidding. There really is imaginary numbers. We're going to study them this year. Okay? Not yet. That's a little bit more foreshadowing. Yeah. Now, what symbol do we use to represent real numbers? Now, the fancy R, right? So for the record, I have drawn this several times for you already, correct? And even though I've drawn it several times for you already, somebody still already this morning thought I was writing an IR. We've had that conversation, right? It's a capital R, but with 2 bars on the left-hand side, and then it's an R. Can you handle that? Awesome. Now, for the time being, I'm going to zoom in on just this bigger side so you can see a little bit better what I'm writing on this side. Okay, so I'm just on the big side right here. Okay, we're going to start with the smallest set of numbers in this real number section. Okay, these kind of numbers are called natural numbers. What symbol do you think we're going to use to talk about natural numbers? If this is the symbol we use to talk about real numbers, what kind of symbol do you think we're going to talk about natural? Oh, but not just a regular N, right? A fancy N. Okay? So N, but N. It's fancy. I'd rather it be in the middle. Okay? Because what I'm going to do is I'm going to talk about this specific set of numbers. We're going to put like an oval around it. Circular-ish, oval-ish shape. So when you learned how to count, how did you learn how to count? 1, 2, 3, 4, right? So on. Guys, those are natural numbers. 1, 2, 3, and so on. And in fact, they are sometimes called counting numbers. Our textbook uses natural, so we're going to go with natural. Okay? The next set of numbers, now notice where I'm drawing this oval. Oh man, that's so messy. Sorry. This next set of numbers includes all the natural numbers. And it's called whole numbers. What symbol do you think we use for whole? But not any regular W, a fancy W. Yes, it does sometimes help to make the sound. Okay? And that's kind of messy, so I'm sorry for that. I did a neater one last period. So what is included in whole numbers that's not included in natural? 0. That's it. 0 is a whole number, but it's not a natural number. So here's a tricky question. Are you ready for a tricky question? Is 2 a whole number? Yes. It's inside the oval with the whole numbers. It's specifically a natural number, but it's also a whole number. Does that make sense? Okay. Now the next set of numbers are called integers. Guess what symbol we're going to use this time? That's a really good guess, but not this time. Yeah, for real. I think an I maybe looks too much like a 1. Even a fancy I would look too much like a 1. And it's possible, although I don't know because I don't care, that maybe integers in a different language starts with a different number. I mean, letter. Shut up. So we're going to use a fancy Z. Or someone last period suggested it was integers. I said, okay, that works too. Uh-huh. What is included in integers that's not included in whole numbers or natural numbers? Negatives. For example, -1, -2. Oh, you guys are so creative. -1, -2, and -3. -706. Perfect. So, we're done with the little sets of numbers, but see, this is still encased in this this rectangle on the side, and this rectangle on this side is called rational. Guess what we use to represent rational? Try again. We already have a fancy R. Fancy Q. I don't care that you don't like them. We still have to use them. So fancy Q. Guys, what does rational mean? What kind of numbers are rational numbers? Can I give you a hint? Look. Yeah, fractions, right? Fractions and decimals. For example, 1/2, 1/4, 1/76, What are you forgetting? What are you forgetting? They can also be negatives. They could also be decimals. For example, what did you say? 0036. Negative 0.0036. So basically anything that can be written as a... I'm making the F sound. It's not the one you're thinking of. Yes, fraction. That's correct. Okay? Fraction. Anything that can be written as a fraction is a rational number. So that implies that this side would be, what's it called? Irrational. And it's anything that can't be written as a fraction. For example, pi square root of 7 my personal favorite. I know that your whole life people have told you that that is a letter. Well, that's because it's true. But in math, we also use it to represent a number. Okay? Guys, this is not a variable in the sense that we could use x and y and z as variables, value, things that change value, right? This is a definite specific number, and when we get there, you'll learn about it. I'll tell you what number it is and everything. 2.81828, just if you're curious. I think that's correct. Okay? But this is a number. We use the letter to represent a specific number. It's not a variable. That's why I can put it over here in the irrational, because it cannot be written as a fraction. Okay? Any questions about this? So, these are the first part of our notes today. Okay? You're going to want to refer back to these quite often. So in your notebook, behind your second divider, which is your third divider, which is notes, and I know you don't have dividers yet, and that's okay. So just have it in your notebook for now. Your worksheet needs to go first, and this goes second. Okay? Because even though your worksheet, we had homework problems on it, we're going to use it as notes. We're going to refer back to it. Okay? But for now, go ahead and keep this out. But while you have your notebook open, grab a couple pieces of notebook paper and let's take some notes. Specifically about the homework that we're going to be talking, the concepts, about what we're going to be talking about today. Probably just one. Unless something changes, I'm going to give you 3 or 4 examples, and then you guys will be able to get to work on your homework. And what I mean by unless things change, like if we have trouble understanding it. Okay? All right. I strongly recommend, very, very, very strongly recommend that when you start taking notes today, the first thing you write down is the date. Because later on you may want to refer back to these notes, and you know when we did it because you know the homework. When the homework was, you can look up the date this way. Okay? So you have the date on your notes, and let's talk. I would like you to give me the list of integers greater than -4. In order to be able to do that, you've got to know what an integer is, don't you? Oh my gosh, I remember what an integer is. And if I don't, I can look back. Right? What is an integer? Negative and positive, like whole numbers. I know there's not negative whole numbers, but you know what I'm saying, right? Those are integers that we're talking about. So what's the lowest integer greater than -4. -3, what's next? -2, what's next? And then? Okay, wait. I'm starting to see a pattern here. Are you? The next one is 2, and then 3, and then 4. How far does it go? Okay, so I literally cannot write them all, can I? I would be working until infinity, right? Or through infinity, or however you want to talk about that. Is there a way I can tell my reader or myself that this keeps going without having to list them all? How do I do that? Think more of English right now than of math. Our 3 dots, our ellipses, right? I could write etc., but this is more mathematically correct to do that way. It keeps going. Oh no. Pretend I spelled it right, okay? I need a list of integers less than 2. So what's the lowest integer less than 2? Not the highest, the lowest. Infinity, right? I don't write that, do I? What do I write? I start with the ... this time, right? Where do you think I ought to start my list? That's where I'm going to end it, right? I'm going to end it at 1. Where should I start it? I could start it at anything. 0 would be fine, -2 would be fine, -1 would be fine. Okay? I'm not going to tell you there's a right or wrong answer here. You need to have at least 3 numbers on your list in a place like this. But notice how many did I have up here? I had 5, right? Okay? So somebody suggested -2, so I'm going to start at -2. That's appropriate. That's correct. Guys, how come I didn't include 2 on my list? What would it have to say in order for me to include 2 on my list? 2 less than or equal. Excellent. Okay. Oh, Jiminy Christmas. What about this? Odd numbers less than 10. 9 is 1. 7 is 1. 5. Where do I stop? I do this time. Okay? Typically, if we're talking about odd or even numbers, we're only talking about positive. Okay? They might specify odd negative numbers, and that's weird. But you would know what they were talking about, right? -3 would be an odd negative number. Okay, you see what I'm saying? Typically when we're talking about odd numbers, though, we're only talking about positives. Okay, so this time, what's the lowest odd number less than 10? 1. 1. Then what? 3. And then what? And? That's it, right? Because I want it less than 10. So this time I don't have any ellipses at all. I start at a number and I end at a number, and every number in between is included, right? Any questions about that? So if I ask you for a list of numbers, you may need to refer back to this if I'm talking about natural numbers or integers or rationals, but you have this to look back on now, right? Okay. The next thing you're going to have to be able to do on your homework is read a number line. Can you do that? I mean, I hope so, since you're in Algebra 2. But if not, that's okay. I'll help you. But here's the deal. I need you to be able to write this domain in 3 different ways. Not just 2, but 3. All right, how's my writing? I've been told before that my writing is messy and hard to read if I write in cursive. Are you guys okay with it? Can you read when I'm writing? Okay, I try to write neat for you. And writing and printing takes me longer. Okay? Do you recognize any of these sorts of notation? On our worksheet, we've been writing the top two every time for domain and range, right? We've been writing the middle one, for intervals of increase and decrease, right? So let's make sure we remember how to do that. Which one would you like to try first? Inequality, okay? So looking at this number line, basically everything in between -2 and 5, but -2 is not included and 5 is included, right? So it's going to look like -2 is less than x is less than or equal to 5. So x is between -2 and 5. It's greater than -2 and less than 5, right? But less than or equal to 5 because 5 is included and -2 is not. You okay with that? What does it look like in interval notation? From -2 to 5, -2 is not included, 5 is included. I like that sound, by the way. Oh, okay. Set builder notation, you already know how to do. Can I prove it? You may know how to do it, but it's super easy. So can I show you? What is set builder notation really close to? Yeah, it's almost exactly the same as inequality notation, right? The difference is set builder notation uses braces. These are pretty braces. We tell the reader, we are talking about x. If for some reason we were talking about a range, what letter would be here? Y, okay? But today is all about domains. We're talking about x for sure. And then we have a vertical line. It's a separator between what variable we're talking about and then the actual domain. You okay with that? That's set builder. If you've got inequality, you've pretty much got set builder, don't you? Okay? So what we're going to ask you to do in your homework is it's going to say something like, take this number line and write the domain in interval notation. Or, here's the domain in interval notation, you write it in inequality notation. Or, here is the domain in inequality notation, you draw me a number line. Can you do that? Do you feel comfortable going back and forth between these four things? That's what you're going to need to be able to do for your homework. Somebody asked me a question. Sir? Right here? It's not a 1. That's a good question. It's not a 1. It's just like a dividing line. It's just a vertical line right there. Okay? It's saying we're talking about x and we're going to separate our variable that we're using and our actual domain. It's like a separator bar. Ask me.
I was going to ask you if the middle of that line is like color-based.
It is. Yeah. I kind of try to darken it in. Yeah, like that. Yes, ma'am. Yes. Remember on your homework, you need to write the problem number, you need to write the problem, and you need to write the answer. On this, going back and forth, how much work is there to show? There's not, right? So you need to make sure you have the problem written and you need to have the answer written. Got it? Are there any other questions?